Let's learn about quadratic functions, and we're going to first approach quadratic functions by looking at how the axis of symmetry can save us some time. Well, what is a quadratic function? A quadratic function is in the form of ax squared plus bx plus c. And you'll notice that the degree of every quadratic function is 2. So if you have a function of degree exactly 2, you have a quadratic function. Now we can also write quadratic functions in what we call standard form, and that has a outside the parentheses, and then inside parentheses we have x minus h all squared plus some number k. All right, now h and k are really important. They are the coordinates of the vertex of the graph of this quadratic function, and every quadratic function will give us a parabola. Now if a is less than 0. If a is negative, then the parabola is going to open down like that. But if a is positive, if a is greater than 0, then the parabola will open up like that. Now, here the highest point is going to be hk, and here the lowest point is going to be h comma k. So let's say that I just had some random h comma k. Okay, so there's h comma k. Then my parabola would open up if a was positive, and if I had another h comma k right here, if a was negative, it opened down like that. So let's do it with some numbers, okay? You'll notice that a is -1, so we know we're opening down, and I'm going to do an xy chart, or actually an f of x chart, because we're talking about functions now, right? And in the middle of my chart, I'm going to put my parabola. Now, you'll notice there's always x minus h. So whatever comes after the negative sign is h. So in this case, h is positive 3. And then this is plus k, so k is 4. And I'm just going to count back 1 from h and back 2 from h. And I'm going to plug these numbers into my function, okay? So 2 minus 3 is -1. Squared is +1. But then it becomes negative again. So it's -1. Plus 4 will give me 3. And then if I put in 1, 1 minus 3 is -2. Squared is +4. But then it becomes negative, so it's -4. Plus 4 is 0. All right, so I'm going to go out to the point 3, 4. And I'm going to plot my points here, 2, 3. And 1, 0. So this parabola is going like this. Now, every parabola has an axis of symmetry. What's the axis of symmetry? It's the line that goes right through the vertex, and we call it an axis of symmetry because what that means is the left side will have an exact match on the right side. So if I went back 1, down 1, I'm going to go over 1, down 1. And if I went back 2, down 4, I'm going to go over 2, down 4. And if you know the axis of symmetry, you only have to graph half the points. So I know that if I went back 1 to get 2, then I go forward 1 to get 4, and I'll have the same y coordinate. And if I went back 2 from 3 to get 1, I'll go forward 2 from 3 to get 5, and I'll have the same y coordinate there. Now, unfortunately, not all quadratic functions are given to us in standard form, so we have to play around with it and work on it so it does fit the form f of x equals a x minus h squared plus k. So we're going to make this look like that. We're going to do it by completing the square. The first thing I'm going to do is factor out the number in front of x squared from the first 2 terms. Now when I factor a 1/2 out of -4, that's saying -4 divided by 1/2, so I'm going to get -8. I'm going to leave a space. I'm going to close my parentheses, and I'm going to leave this number here, this constant, all by itself. It's not going to change, okay? Now, inside the parentheses, I'm going to complete the square. That means I'm going to take half of this number, which is -4, square it, which is 16, and add it inside. I have created a trinomial square, which we'll see in just a minute how it factors. Now, what did I add to this side? I actually added a 16 times 1/2, so I actually added an 8. So to keep it balanced, since I added an 8 to this side, I'm going to subtract an 8 from the same side. Okay, so now I have 1/2 And this trinomial square will factor into x minus 4 times x minus 4, and 3 minus 8 is negative 5. Hey, look at that. That is now in that form, isn't it? So we know that h is, let me put an equal sign, h is 4, and k is negative 5. All right, so let's graph it. So I'm going to go to 4, negative 5. So 4, negative 5, right there. Is it opening up or down? Well, 1/2 is positive, so it's opening up. And just for reference sake, I'm going to rewrite my equation here. So it's 1/2 x minus 4 squared minus 5. And I'm going to do my f of x chart. And I'm going to put 4, negative 5 in the middle. And since everything inside the parentheses is being multiplied by 1/2, I'm going to go with multiples of 2 so that I get a nice even number and not deal with fractions. So I'm going to go subtract 2 from 4, and I'm going to subtract 4 from 4. Okay, so 2 minus 4 is negative 2, squared is 4, half of 4 is 2, 2 minus 5 is negative 3. Wait a minute, 0 minus 4 is negative 4, squared is 16, half of 16 is 8, 8 minus 5 is 3. And remember that we have an axis of symmetry going right down through our vertex, so whatever happened on the left side of my vertex will also happen on the right. So remember, I subtracted 2 from 4 to get that number. I'm going to add 2 to 4 to get that, and I'll have the same y coordinate. And then I'm going to subtract 4 from 4 to get that. So I'm going to add 4 to 4 to get that, and I get these points. Now let's just plot them. Okay, so I've got 0, 3, 2, negative 3, and go straight across to 6, right there. Hang on a minute. I've got to erase that point because I messed up, didn't I? Here is 6, negative 3, and 8, 3. And we've got plenty of points to know what the shape of our parabola is now. So there you go. That's how you graph a parabola that is not in standard form. You complete the square first to get it in standard form, then you graph it like normal.